So yeah, everyone, thanks for coming. Thanks for your patience on this. Got Kunal as well coming in. Yeah, I guess we're just starting off the second challenge now, NFT plus front end, and I've got Dennis here to sort of go through, what NFTs are, how the challenge is going to be progressed by you guys, and how to actually execute it. So all the information he's going to go through with you guys to really go through this challenge and yeah, get the most out of it by creating your first NFT, minting it, and creating the front end for it as well.
Great. So I'll kick off. Welcome, everybody. I will share my screen now to walk you guys through. Let's see what I want to cover with you. So there we go. We should be good now. So yeah, your first challenge, NFTs and a front end for it. So it's two parts to it. You're free, of course, to choose whatever framework you want for the front end, and yeah, for the smart contract part of it, you can choose between our experimental JavaScript SDK for smart contracts, or our assembly script, which is no longer supported, or Rust, which is the most recommended, the battle-tested way of writing smart contracts on here at the moment. So what is an NFT and what is an FT? NFT stands for non-fungible token, and FT stands for fungible token. The difference between these two is an FT can have two or more versions of itself, and an NFT only has a single one of them. So as the name suggests, one of them is unique, and the other one not so much. There can be collections of NFTs, as some of you might know, and there can be only one NFT. But with FTs, you can have as many as you wish, and you can keep adding to the supply or reducing the supply. In any case, the difference between them is that, well, yes, the fungible token is only is fungible, so you can have many copies of it. Ultimately, I think I'd add a couple things more to this. I think the NFT as well is an NFT can really be anything on the context of a blockchain. An NFT can be whatever piece of information that's just being made known to the blockchain at a point in time. So that can be indeed as typical, and we've always seen an image, and then that's associated with an account at a point in time, and that is the minting event. So that informs the blockchain and the entire network that this piece of information is associated with this account, and that's the entire minting. That's what minting really means. But as such, it could be any other piece of information really that's associated with the account at any point in time, and that would also be an NFT, as long as it fulfills with the idea that it's unique and non-fungible. I've seen people ask the question as well as, for example, I have this JPEG and the internet is full of this multiple copies of this JPEG. I can mint it today, but then somebody else will come around and will mint the same JPEG or the same image tomorrow. That's not an NFT anymore. Well, it actually is, because the NFT is a combination of account, when it was minted, and the network, and the information. So as the one who mints it first, that's the one the network can publicly recognize that minted that piece of information first. So and that's an immutable piece of information. So once that's being communicated to the network, there's no reverting that anymore. It's there forever, and that's the first person who minted that NFT, or the first account that did. So the challenge for this assignment is to, as said previously, twofold. You guys can make an NFT minting smart contract and a web UI to perform this action. As mentioned, the network requires two pieces of information really in order to perform this action, to communicate this action across the network. One of them is what account this piece of information will belong to, and what piece of data are you attaching to it. So as such, we can talk about metadata now. Feel free to ask questions in the meantime. Right now, I'm just looking at my presentation screen, so I won't be able to see the questions interactively as I did last time, but I'll get to them towards the end of the presentation, unless it's really pressing and I hear from somebody, I got to answer it right now. But yeah, I'll continue, and then at the end, I'll touch upon your questions. But yeah, so as mentioned, any NFT minting event has data accompanying it, and during this event in which this piece of information is communicated to the network. There are standards for this. More specifically, I think out of the top of my head, it's the NEP 177, if I got the number correctly. NEP stands for Near Enhancement Protocol, I think, and or Near Enhancement Proposal. I think it's the second one actually. And these NEPs, they're very similar to other pieces of standardization in other blockchains. It's basically a description in well, human language, usually English, of course, that proposes to other developers and people in Near that we should standardize a given set of information. A given set of information. Like in this case, it's the NFT metadata, and I think this Near Enhancement Proposal included also the metadata for fungible tokens. So it did standardize both of them in one go. Writing NEPs is not straightforward. There's a very strict format in which to do that. That's also, I think, specified in github.com/near/ I think it's called NEPs or Near Enhancement Proposals, one of these two. And in that repository in GitHub, you'll find in detail how to write an NEP. It's not an easy task. It takes the best people out there also a good while to write it out, because it's detailed and it's got to be thorough. Because once it's implemented, as is with blockchains, once something is really implemented throughout the network, it can't really be rolled back. Once it's out there, it's really out there. So yeah. But going back to NFT contract metadata, in this case, it's quite straightforward. It's 7 fields that you can include, 4 of which are optional. So in essence, you need a spec, which is described there. You can follow this link. I found this by literally looking for NFT metadata and Near protocol on Google, and the Nomicon article here. Nomicon is one of our tech spec sites. In there, it's also included in detail how this looks like. I'll run through a couple of examples as well and tutorials later on in this video, and those are also very helpful for this particular case. Yeah. So this this is the basic structure you can expect. Yeah. IPFS. Yeah. So as mentioned, an NFT can be any piece of information, and the minting event is when you communicate that this is associated to an account throughout the network. But sometimes the piece of data, as with a high resolution image, can be lots. So sometimes it could be say it's a video. It could be a video of 4 gigabytes. And for reference, generally storing data on blockchains is very, very expensive. Is just really absurdly expensive. I think Near is among the cheaper ones, but it's still very expensive. I think 1 megabyte costs 10 Near. So with the price of Near at the moment, that's approximately $55. So for 1 megabyte. So yeah, you can imagine if you want to associate multiple images to multiple users, and you want to save those images on chain, then that's going to become very, very expensive. So you could go down that route, saving data on chain. I'm paying for that because there's a storage cost, as I mentioned, associated with that. Or you can save in your metadata the URI pointing to where this image is. So in such case, you're not saving the entire all the bytes of the image on chain. You're saving that somewhere else, and your metadata includes the reference to where that is out there in the internet. So what is IPFS? IPFS is a shared storage solution, very similar to what some of you might know in Dropbox or OneDrive or Google Drive, these kinds of cloud storage solutions out there. But the difference between IPFS and these previously mentioned ones is that these previously mentioned ones are centralized and commercial, and IPFS is a peer-to-peer storage service run by, I think, volunteer machines. I'm not sure if there's an incentive mechanism behind it. But yeah, that's the general gist behind it. They also have an API, I believe. You can also make use of that to for your front end to fetch the images from IPFS using the data that you saved in the NFT metadata that points to the image. So in essence, you don't need to have a server running yourself to host these images or anything. The data of the image itself is stored here, and the metadata is stored on chain. So yeah, so as mentioned, there are some quite useful resources out there. You could look into the my favorite is on the area of NFTs, exactly as the near NFT zero to hero tutorial, and that's, I think, the most comprehensive near tutorial we have right out there at the moment. So but for this particular assignment, I think you'll just need the first 1, 2, not sure if the third one as well, chapters in this tutorial. This tutorial has about 9 chapters. It's a multi-day read. You can feel free to read, of course, the rest of the tutorial as you wish, but the last 6 chapters are not so relevant for this assignment, as they go into other things in detail, as like running your marketplace, implementing royalties into the NFT pricing and transactions on the marketplace. So these kinds of added features that, well, aren't really what this assignment is asking you to do. And there's also an NFT example out there as well. I think the NFC zero to hero tutorial has a more robust Rust code, but this NFT example also has a nice example of how a Rust smart contract code looks for something for a smart contract that mints NFTs. Yeah, and from previous competitions, there's a couple of examples out there. I'll add this to these slides. Yeah, I think we could probably just visit a couple of them. So yeah, let's see this. So this is all on testnet. It's asking me for a function call key. So and here you have full access keys and function call keys. This one does the right thing and asks me for a function call key. So yeah, here is, I think it's a piece of, yeah, it's an image which we're going to mint. And it requests for 0.1 year. We can look at these transactions on the Explorer in a moment. Check your wallet. Oh, that's nice that it gives me a little pop-up with that. So this is my testnet wallet. Yeah, these are my past minted NFTs. Oh, and there's the assignment NFT. So that looks great. So let's see, recent activity. We can go here and see what the heck happened in these last 5 minutes. So yeah, so this is me adding the key. So this is the function call key I added to that assignment just now. And this is me calling the NFT mint function in the smart contract deployed to this account. So this is the account. Yeah, a bunch of NFT mint calls performed to it. Let's see if we can get some more details behind it. Yeah, this is how that looks like. Yeah, it looks all very good. He is storing it in storage share. Storage is, yeah, I knew these guys from 2017. It's also like IPFS, but it is an own blockchain in itself, and it has an incentive system for their own version of validator nodes, which are actually machines that have terabytes in storage probably, and they get crypto for making these terabytes of storage available to the network. So yeah, so that's where that image of that little astronaut is saved here. So yeah, it all looks very good, and yeah, I think yeah, the other one's probably very similar. So I'll stop presenting right now. I heard a couple sounds, so probably that's a couple questions. So I'm gonna jump to that. Let's see. Right. So I'm going to start from top to bottom. What thing differentiates NFT and NFT tokens? NFT can have a limited supply, and FT also. Yes. Well, in essence, it can, but the difference between an NFT and an FT, as I said before, is with the NFT, you have the difference in which there's always one that's being minted first for that given piece of data. So all the subsequent ones that are also minted for that piece of data are unique in their own right, in which because the block in which they've been minted is taken into account. So you have the NFT minted for that exact same data at block 0 is not the same as the one minted on block 2, because the one minted on block 2 was minted on block 2, so that's later. And with FTs, it's actually one kind of NFT, if you want to see it like that. And that was created at one point in time with the deployment of the smart contract to that account, and then that's sent it's sent, distributed, or sent across the network across after every block. But they're different in essence because the FT has a bunch of different copies within its first creation moment, and the NFT, when it's first created, it's only created that once for that given piece of data, and FTs are created then 2 or more, which can be subdivided as much as you want and sent wherever you like. With the NFT, you can only associate it to one account, that piece of data. So that's the difference between that. So what is the token ID of an NFT? That is an arbitrary, I think it's either string or integer, which can be anything which you can associate to it. What you often see is that the smart contract that performs the minting carries through this number. So very much like an SQL database would do with an index, your smart contract would auto increment this ID for every new NFT mint event, and push that through in the NFT token metadata that is given, that's communicated to the network once the NFT mint event is triggered. Why should I build smart contract to mint NFT while I can use IPFS directly without smart contract? Could you please advise? Yes, you could use IPFS and save your image, and but keep it there, and maybe nobody else has that image. You're the only one that has access to it. Fine, but it's not communicated to the near network. That's the difference. When you mint an NFT, you're telling the entire near network, hello, this account is associated to this NFT, the other way around. So yeah, if you keep it in IPFS and do not use the NFT mint event, then the near network is unaware of this NFT being associated with any near account. So that's the difference. So how could I buy an NFT? Sorry, sell an NFT. Well, that's a different topic, not a topic for the assignment you guys are doing, but considering I have the question here, um, well, the questions stated are quite brief, so there's many ways to answer them. How can you buy them? You'll need, but the short version of it is you need a marketplace to buy and sell. And the marketplace in itself will be its own smart contract that is concerned with making sure a payment is received. The NFT is then sent from, deassociated from the previous account and reassociated to a new account. That means that that NFT metadata associated with that minted NFT from long ago has a new owner, and as such, because of that transaction, is associated to a new account. And that's what happens during buying or selling, or on an NFT transaction, is that the NFT acquires this new owner, and there's a transfer of either NEAR or some other fungible token that occurs at the same time. So how could you buy them is a short version, implementing a marketplace contract, or going to somewhere like Paras. It's a website that does exactly that. I'm not sure if they're open source. If they are, that's of course very handy. Otherwise, the NFT Zero to Hero tutorial has a very nice run through on how to implement a marketplace for NFTs. But otherwise, the Paras website I think is the most common one for NEAR, where you can perform these kinds of transactions. Can we know a bit about coding? Yes, you can. That's a very general question. I really wonder how to answer it. I think I'd like to ask you to ask it again, Kuno. So I'm going to move to the next one. I have a good knowledge of Solidity to develop smart contracts, and not very good in Rust. Can I use Solidity with NEAR, especially on challenges? Thank you. Osama, yes, you can. You can deploy your Solidity code to Aurora. Aurora is A-U-R-O-R-A. You can Google it, Aurora EVM NEAR. It's exactly that. It's an Ethereum virtual machine that actually runs your code on the NEAR blockchain in the background. So, and I think people can interact with your Solidity code that's running on the NEAR blockchain using their MetaMask wallet. So exactly how that works, haven't done it. There's a dedicated Aurora team. They also have their dedicated Discord channel. But because that's also NEAR, we accept generally, we do generally accept submissions that are done this way. If you feel the most comfortable with Solidity and just want to deploy it quickly, and you feel more comfortable how this works, you don't really want to make the leap into Rust, then yeah, this is a very viable option. We also take these submissions indeed into account. So yeah, check out Aurora. They do have a dedicated Discord channel, so have a look at that. Yes, yeah, Dominic answered a couple questions. Sala, great, yeah. Okay, how can we structure NFT contracts? What library we use if we're using Rust? Great, good questions. Okay, yeah, that's more tangible. So yeah, how do you structure your NFT contract is the NFT repo that I mentioned from GitHub is a great example. I think it's simplistic, and it showcases how that should look like. So basically, you have one struct that's called in Rust. In other languages, you know this as a class. So you have one class, which is called something contract. You could call it minting contract or whatever. And this class has its NFT mint function, and it requires it's initiated with some standard fields, which you'll see there too. There is a new function there that's the constructor, as you know it in other languages as well. The new function initiates the contract on the blockchain once it's been deployed. After which you can call its NFT mint function, which is also implemented there. And the NFT mint function asks for those previous 3 fields, I showed that were non-optional, and the other fields that are involved in the NFT metadata. So yeah, if you look at through the examples, you'll be able to run through with that. So the struct is a class. The new function is your constructor. Now the funny thing is in Rust is that the struct is a little bit, when you declare your class, you first declare it in an isolated way in the code, and then you have to declare its own class methods after in another piece of code. So yeah, that's just the way Rust works. But you'll see you declare your struct first, and the data structure of your struct, and then after that you I think it's you implement your struct. There's this impl there's this impl abbreviation, but it will also have the name of the struct. You'll see it in the examples, and that includes that then specifies the class methods that are associated with that struct. So yeah, that's a little bit the structure of how that will look like. The examples are a great place to look for this. Will the links for the examples tutorials shown in the presentations be on Discord? They can certainly be. Yeah, for sure. I'll make sure that is. I'll share them with Ron as well after this call. Allura, is the name? What is it? No, it's not Allura. It's. I'll type it right now. Sorry. I'm not speaking clearly. What is it exactly, and how can I get the Discord server? Oh, the Discord server is a good question. Let's see if I can share the link of the Discord server because I'm in it as well. How do I do this? Invite people. There we go. Copy. So this is the Aurora Discord server. In case you guys have Solidity code and you want to go down that route. There is a struct metadata and metadata that we upload while minting. They are both different. Yes, they are both different indeed. The further metadata specifies additional fields, like I think it even has a fallback URI. You can even add extra fields to that metadata as well in case you feel that's required for your use cases. But yes, and also the way these smart contracts are implemented, they're implemented using standards, which are guidelines. So you don't have to do it this way. As I mentioned at the beginning, the essence of NFT is associating data to an account. So you could choose a different implementation, but these standards are what came out of the NEP 177, I think it was. And as such, I think different applications in the ecosystem look for these kinds of data structures and these names of functions. So for example, there's an application out there called SecondX. What they do is they just look through all NFT mint events. So they look for all functions that have been called on the Near blockchain, which are called NFT mint. And based on that, then they look for the specific field name, which is I think it was called something URI, and it looks for that link, which is either IPFS or something else, and that's where it gets the images from, and it shows all minted NFTs historically on Near by doing this. There's more details to this, but this is a little bit the high level way of how that works. But that's the role this standardization or this enhancement proposal plays by standardizing things, by giving things the same name and the same way of or a standardized procedure for doing these things. You can allow other applications to reliably fetch this kind of data throughout the blockchain for everything that's been done in this domain. So yeah. But also proposing your own Near enhancement proposal is also up there. So if you also have a particular use case you'd like to implement and you see it's quite niche, and you figure, well, other people might want to do it this other way too, may it be adding some nesting to the metadata or making sure a couple fields always have these names, then yeah, everyone's free to propose a near enhancement proposal as well for doing this. Please drop an invite. Don't have access. Yeah, I shared the Aurora link for the Discord service. Yeah, Discord server. Great. Yeah, so I think that's all the questions. Can we add our own NFT metadata? Yes, of course you can. Yeah. So it's advised you don't have to copy and paste the values of the metadata, but the keys and the name of these keys, it's good if you keep those names in it, because of what I mentioned before. There are other applications out there that might be looking for that. Maybe you might also want to interact, or the NFTs minted through your contract might want to interact with an NFT marketplace, and the marketplace might be looking for these particular key names, not the values. It doesn't really care about won't find the values if it doesn't find the keys first. So the key names, it's probably better if your key names match with what the proposal, with what the standard is. And yes, you can add further keys, as many as you want, and then with the new keys you add, you can add nesting into that, so you can add an infinitely complex data structure to the NFT data and metadata if you wish. Out of topic, I couldn't find the briefs challenges. Could you please? Oh yeah, Ron answered that. Great. So I think that's all the questions now. Ron.
Yeah, I think that's everything covered on our end. And just for everyone's clarity, we're going to drop all the info that Dennis has given in terms of the Zero to Hero NFT tutorial, the GitHub, and all relevant information to you guys on our Discord, so you can go through that self-paced and then actually do the challenge after. So yeah, look out for that. If there's any else, does anyone else have any other questions? Because yeah, we can wrap it up from then. No? So yeah, guys, thank you for coming. Dennis, thanks for the presentation. As I said before, I'll drop all the information on Discord for everyone to read through.
Yeah. Thank you too, Ron. Thank you guys all very much, and have fun doing it. Looking forward to the submissions, and I'll see you next week probably, because on Saturday I'll be there for in London to see most of you as well. I'll give a chat as well, and I'll walk around for a couple hours. So thank you all. Bye-bye.
All right. Thanks, Dennis.